Hello everyone, Jim Kim here again, and today we'll be talking about how our blood flow is maintained and what cells actually make up the blood. Before we get started, I wanted to share with everyone that we've just reached 1,000 plus views on our channel. This, however, also means only 3.5% of our viewers actually subscribe to the channel. So please, if you enjoyed the content, make sure to like, subscribe, and share for more intuitive anatomy contents from our team. With that being said, let's get started. So back when I was learning hematology, I had a hard time conceptualizing what is going on inside our blood, because it's not like your heart that you can feel and easy to visualize. Since blood cells are microscopic, we cannot visualize that easily. So I want this video to provide a basic conceptual understanding of our blood that I wish I had when I was learning about the blood. It's not just this red, viscous drop of fluid that you get sometimes when you accidentally scrape yourself. There's so much happening not only inside that drop of blood, but also our body has a fascinating way to keep our blood flowing through a process called hemodynamic homeostasis that I'll be introducing today as well. Also, stick around if you want to learn why doctors say hypertension is so bad for your heart and why it's one of the leading causes of heart attacks in the United States. So here is our male model to remind you that everything about the blood I'll be going through today is happening right inside your own body with the heart right there. As long as you're alive, there's blood flow everywhere in your body. In our previous video, we discussed about the heart and how it pumps blood through its pulmonary and systemic circulations. In this video, I want to talk more about the fate of blood when it exits the heart. So here is a simple model of the systemic circulation of the blood that I'll be showing right here. And when blood leaves the heart, it first enters the arteries, which are being highlighted right here, which has three major layers, and its inner layer is lined by these flat cells called endothelial cells, and their basement membrane, as I'm trying to highlight here, there creates a tight wall that surrounds the lumen. The next outer layer that is more thick is your tunica media, which has these smooth muscle cells that allow constriction of the arteries when your blood pressure gets too low. Then the most outer layer, as being highlighted here, is your tunica adventitia, which has its own unique circulation system called vasa vasorum, as being highlighted here. And this is because tunica adventitia is too far from the lumen to receive nutrients directly from the blood or through a process called diffusion. These vasa vasorum vessels are lined with nerves called nervi vasorum, which trigger the constriction of the smooth muscle cells when the blood pressure gets too low. The artery then drains its content to arterioles, which are lined by smooth muscle cells as well. And here's the arteriole right there. And the blood then gets dumped into the capillary network where oxygen and hydrogen ions are exchanged in the red blood cells to carry out carbon dioxide out of the body. And this is where oxygenation of your muscle cells, your brain tissues, and your kidney cells actually take place. Now, all the oxygen-poor blood is then drained into venules, as being highlighted here. Then venule drains into the veins, as highlighted here, which have very similar layers as arteries, except its tunica media is thinner. This allows the veins to be more compliant and easily collapsible. And this is because veins drain directly into the heart and must maintain a low blood pressure to keep the blood flow from the high blood pressure from the arteries to the low blood pressure to the veins. So now that we discussed the basic components of the blood flow homeostasis, I would like to briefly discuss how high blood pressure works and why it's so bad for you. So let us remind that the left ventricle of the heart sends oxygen-rich blood into the arteries and veins, which then ultimately drain into the right atrium as being shown here. High blood pressure or hypertension can be caused by a variety of ways. It can be because your kidneys aren't receiving enough blood flow to function, or your body is producing too much stress hormones like cortisol. Yes, stress can cause hypertension, so please take it easy on your body sometimes if you have to. Unhealthy lifestyle can also cause high blood pressure, specifically food high in sodium in your table salt. If we go back to this diagram here, there's an old saying in my medical school that says, Where sodium goes, water goes. When you eat too much salt, there's more sodium in your blood, and that pulls more water into the heart, as being shown here. As the volume expands, it'll expand against your vessel walls and put higher pressure against those vessel walls, as being highlighted here, hence leading to higher blood pressure. And this process can actually backfire back into our heart, because now the increased blood pressure is putting more pressure against one of our 4 major heart valves called the aortic valve, as being shown in this green line here. This means that it'll take more energy for the heart to pump blood against your body's own blood pressure, and that over time leads to heart failure by enlarging this heart chamber left ventricle, as being shown right here. Hypertension chronically can also damage the vessels and literally rip open your vessel lumen. This exposes our body's fat and cholesterol into the inner layer of the vessel wall and causes this thick, fatty, inflammatory plaque, as being highlighted in these yellow goo here, that can occlude your vessel walls over time. And when this happens to one of your coronary arteries, which supply the heart itself, it can lead to heart attacks, also known as myocardial infarcts. And you can see this change of blood flow direction because of that occlusion there. And to celebrate the 1000th view of our channel, we'll be uploading a special EKG analysis video to understand how it works and why it's so useful in monitoring heart attacks. Now that we understand how high blood pressure can actually cause heart attacks, you can start by controlling your daily intake of sodium. Keep it below 2.3 grams of table salt a day, and if you want to maintain a healthy blood pressure, exercise. And finally, I would like to discuss the actual cellular component of the blood itself. So these spaceship-looking cells that are being highlighted are red blood cells, or erythrocytes. They are the cells responsible for carrying oxygen to your cells. Your blood is packed full of them, and even a single drop of blood contains a huge amount of these cells. Next, we have these more round cells as being highlighted, which are lymphocytes, aka your T cells and B cells. They're responsible for making sure your blood is clean and there are no infections. If you ever catch the flu, you'll see much more of these cells. In fact, one of my favorite T cells is the killer T cells. This cell is cool not only because its name is awesome, but also because it literally searches for any viruses in infected cells, like a TSA agent at the airport patting you down to make sure you don't have anything fishy. Then being highlighted here are basophils, which are slightly bigger than red blood cells, but are more blue. This fine texture comes from releasing histamines when you're allergic to something. If you have seasonal allergies, like me, it's because you're allergic to the pollen in the air. And when it gets into your nose, the basophils recognize them as foreign and release histamines to dilate the blood vessels, leading to a sneezy and snotty nose. Then we have these eosinophils as being highlighted here, which have similar functions as basophils, but they're mainly responsible for clearing parasitic infection. And last but not least, we have these monocytes, which can get activated when there's infection into macrophages and clear infection in tissues outside your blood vessels. In fact, when there's an infection, say a bacterial infection as being shown by these red squiggly cell here, there are white blood cells, like dendritic cells, as being drawn right here with label DC. And these cells release danger signaling molecules called cytokines around them, as being highlighted by these green structures here. And when they enter the blood vessels, they actually recruit other inflammatory cells, like your monocytes, your lymphocytes, your eosinophils if it's a parasitic infection. And these cells then can cross the blood vessel wall and directly enter the tissue and clear the infection. Now, let's say the infection didn't get better and it actually led to the blood vessel wall to get teared apart. And now there's massive hemorrhage of blood leaking out into tissues. What do you think is going to happen to your body? What's likely going to happen is these little bean-looking structures as being highlighted here. These are called platelets. And these are almost like cells except they don't have any nucleus. But when there is huge leakage, like here, these guys will start lining up to cover it up and stack up to form this plug to prevent more blood from leaking out and to prevent the bacterial infection from spreading to your circulation. Now, they also release these coagulation products called fibrin and thrombin to interlock with each other and further stabilize this blood clot plug. While this happens, we have cells repairing the injury site, as denoted by these black structures here. Then our blood carries these molecules called heparin and plasminogen activating factor that start loosening up these tight network of platelets until they're completely dissolved. And all that's left now is the scar tissue. This is what would happen to young people in their 20s, but in older patients, especially those with hypertension, those plaques that we just discussed about the coronary artery being clogged, can actually tear open and rupture, leading to blood hemorrhage, just like the infection case. In this process, the platelets will be recruited, just like in the previous case, and start piling up to create this plug. Occlusion this plug itself can actually lead to occlusion of the vessels that you're trying to protect. And this leads to occlusion of the vessel, and now the blood flow is being highlighted as these green arrows are completely occluded. And if this happens into your coronary arteries, it's going to cause heart attack or myocardial infarct, or MI. And in our special EKG edition video coming up soon, we'll discuss how heart attack can lead to ventricular fibrillation, how you can use EKG to also diagnose the VFib. So that's basically it. To sum it all up, our body has different mechanisms to control our blood pressure and fight infection if needed. Hypertension can lead to your vessels to occlude and lead to heart attacks if it clogs one of the coronary arteries, or even stroke if one of the blood clots embolize, spread to the brain, and clog one of its arteries there. I know today's video was pretty dense, but that's because I want my viewers to understand how important our heart is. So I hope this video made sense, and if you enjoy the content, please leave comments, like, and subscribe. Share our channel with others, and let's get even more viewers. Thank you, and bye-bye.